So let's take a look at how to graph a line where the equation is in point-slope form. So point-slope form is named because directly from the equation, we can gather information about a point and information about the slope. So in point-slope form, one thing that's unique about the point is that it's just any point on the line. It is not necessarily your y-intercept like we saw in slope-intercept form. So in this form here, your y1 and your x1 values, oops, and I wrote those backwards. X always comes before y in a coordinate point. There we go. Your y1 and your x1, or x1, y1, as we'd write the point, that is just a point on the line. So some point on the line, not necessarily your intercept, okay? And then your m is what m has always been, which is your slope. And these are going to be the two pieces that we're going to use to graph this line. So we're always going to use a point on the line and the slope to find a second point. So let's take a look at how this is going to work. We have to be a little bit careful with point-slope form when we're pulling out this point, okay? Because point-slope form has subtraction in it. So if I have y minus y1 equals m times x minus x1 here. So I need to figure out an x value, right? Need to figure out an x value. In my equation, I see a plus 3. But if I substituted in 3 here for my x1, then I would have minus 3. But that's not what I have in my equation. So in order to get that addition, I need to be subtracting a negative value. So this x1 actually needs to be a negative 3. So we're going to pull out the opposite of the value that we see because of that subtraction there in the formula for point slope. So I'd say, okay, in the original formula, in order to get plus 3, I would have substituted in a negative 3. So my x value is going to be a negative 3, the opposite of positive 3. Now for my y, I have minus 2. Well, if I substituted in a negative 2 there, then I would have plus 2. So I don't want to do that. So instead, I want to substitute in a positive 2, because then I would get that minus 2 in the equation that we're actually substituting in. So again, it's the opposite. So positive 2 is the opposite of that negative 2 in our original formula. So something you always want to remember up here, we'll put it up here, is that we want to be taking the opposite values when pulling these out of the equation. That's because when we plug it in with that subtraction, we see kind of the opposite of the value that we substituted in. Okay. All right, so we have our point. We need our slope. So our slope is still just that value in front of, we can think of it as in front of the x. It's not really a coefficient because it's outside of the parentheses, but that's where it's located. So it's negative 1/2. So just like slope-intercept form, we're going to plot our point first. It's just not going to be on the y-intercept, which is fine. So the point negative 3, 2 is right over here in the second quadrant. And we're going to use our slope. It's negative 1/2, so I'm going to go down 1, then right 2. And I can continue that pattern all the way to the edge of my graph. Or, remember, you can always do the exact opposite. So instead of down and right, I could go up and left. And we can see those points fit nicely on my graph as well. So it lines up. Connect, arrows at the end, and we have a nice point slope form line. Okay, so let's take a look at just a few more examples, get the hang of it really graphing this. So the newest thing about graphing point slope form is pulling out that point accurately and making sure that we remember to take the opposite values because of that subtraction in the original problem. Okay, so our point here, right, our x1 value is next to the x, our y1 value is next to the y, and we always want to take the opposite. So if in my formula, in my equation here, it says minus 2, my x value that I plugged in was actually 2. If in my equation it says minus 3, the actual value I plugged in was actually a positive 3, right, the opposite. My slope here is 2, or 2/1. And then we just need to plot. So the point 2, 3 is over here in the first quadrant. and we're going to use our slope. It's positive over positive. So I'm going to go up 2, right 1, or down 2, left 1, right? 2 positives make a positive, and so do 2 negatives. Once we have a good number of points that we can make a nice straight line, we can go ahead and connect them. So again, pulling out a point, x1 value is next to the x, y1 value is next to the y, and we want to take the opposite. So the opposite of a positive 4 is a negative 4. So when I would go back to substitute in y minus y1 equals m times x minus x1, if I substituted in that negative 4, I'd be subtracting that negative and I would get that plus 4 that I see down here in problem number 2. Opposite of a negative 2 is a positive 2. So there's my point. Slope is negative 1/2. All right, so let's plot that point. Negative 4, 2 is over here in that second quadrant. And then our slope is negative 1/2. So I'm going to go down 1 and right 2. Down and right. Or up and left. Connecting all the points and making sure we have arrows at the end to indicate that a line continues forever in either direction. Okay, last one. Pulling out the point. So we have an x1 and a y1 value right next to the variables that look like them. Opposite of a positive 3 is a negative 3. Opposite of a positive 1 is a negative 1. My slope is 3/2. So I'm going to plot negative 1, negative 3. It's down here in the third quadrant. And then we're going to use our slope. So it's a positive over a positive. So I'm going to go up 3, right 2. And we'll continue that until we hit the edge there. And then I'm going to do the exact opposite, down and left. And I only can get 1 point that way. Connect them. Make sure we have arrows at the end to indicate that it's a line. And we're all done with those 3-point slope form examples.